So now we have like all the basic physics and all in place. So we'll start adding our AI. So what we'll do is first remove all these methods that we have created that is not required anymore, and we'll add our AI and use that like through AI only bird and all will be created. So we'll just keep this util load asset, so it will load all our images, and let's add this handler, and rest of all will happen through AI. So let's add AI folder first of all, where we'll add our AI related logic, and here let's say I will add two files. Let's say neat trainer.js. So here we'll have the training logic, and then AI watcher. So through this we'll watch AI playing. So now that we have two files, let's do one thing here. What we'll do is we'll call the method, the initial method from this AI trainer. So let's create one method and let's export it. Let's say export async function, and let's name it run neat. Okay, let's say for now there is no params, so let's save it and let's call it from here. Okay, so whenever we hit on this train AI method, this method in the neat trainer will be invoked, and here we'll create one method, let's say inside AI watcher. Here also let's say export async function, and let's name it play with AI. Here also let's say no param is needed. Save it, and whenever this run with AI method is invoked, it will pass to that method. Okay, now we'll start with the logic inside this method. So now first of all, like similar to how we had done here, we'll initialize our canvas. So let's go to neat trainer. Before any methods are invoked, let's get like a document dot get element by id canvas. Let's save it into one variable const canvas. Let's set the height and width, so dot width equals to settings dot win width, and canvas dot height equals to settings dot win height, and then from canvas we'll get the context, get context, that is 2D context. Let's name it context. Okay, so now have everything ready. Now if I save it and if I go here, let's see what error it is giving. It is failing to the source settings. Again let's add JS here. So our canvas is loading. I click on train AI, obviously nothing will happen because till now we have not added any logic. So now let's go and add the logic for that. So now since we are going to uh, write this logic, we'll have few variables to calculate the scores, and since we'll use AI and it will run through multiple generations and it will keep evolving, so let's track those things using, let's say, generations. Let's initialize it with 0, and let's say highest score, let's initialize it with 0. Now what we'll do is we'll create the neat configuration. So let's say const config. So like if you see in the index.html, we have added this script So this is through the CDN we have imported it, so we don't need to like install this package explicitly. It will be imported through the CDN, and from this one we'll have the classes related to neat. So we'll use new neat JavaScript dot config, and here basically we'll pass few parameters. uh, so we'll use, let's say, input. So basically it will create the neural networks, and we want to pass like how much input we'll be giving and how many outputs we want, and based on that it will do some calculations. So let's say I want to give input that will be 3, and I want output size to 1. I just want one output. Based on what I can decide like if the bird should jump or it should keep free falling. Then we'll use population size. So it will define like how many like genomes will be there in a population. Means based on this we can decide like how many birds will render, and like for each generation. So let's define that also in settings. Let's say population size, let's go with 100. So we'll have 100 birds in each generation. Let's say pop size, then we'll give generation, like total for how many generations we will try evolving. So let's say max gen. For now let's give 100. We'll anyway not use this much. We'll add our own logic related to that. Max gen, and let's say target fitness. So it defines like after reaching how much fitness it should consider, like okay, this is the best model, it is being trained. We will not use that also much. We'll add our own logic. Let's say it is gonna be 1000 for now. So it is just for the configuration purpose we are adding it here, but we will not use it much. So with this our configuration is created. So let's create the population using this config. So let's say population is equals to new, again we'll use this dot population, and there we'll pass the config. So basically it will give using these config it will create the population, and each population will have like 100 genomes. Genomes is kind of brain that will use and tag it to the birds. Okay, now what we'll do is we'll use await and eval genome. So we'll create one method where basically we'll evaluate these brains and get the best brain out of it. So let's pass our population to this. Let's create this method. So this is also gonna be, let's say, async function, and the name will be eval genome, and it will get the population as input. Okay, now from this population let's get the genomes. Const genomes is equals to population dot genomes. So now here we'll have like 100 genomes, since we have given population size 100, and the initial generation is 0, but what we'll do is we'll make it 1, so that for display it will be helpful to start from 1. Okay, now we'll start creating our birds and pipes that will render on the canvas through the AI, and the AI will pass through that. So let's say we'll create empty birds array, and for each bird we'll have a brain that will be tagged in this one. G is the genomes. So we'll basically convert these genomes to here, because here we'll have all the genomes. Here we'll keep only genomes for the birds that are alive. And then let's say all the pipes that we'll have. Okay, so First of all, what we'll do is we'll create one pipe and we'll push it to pipes. So let's say pipes dot push, and let's create new pipe, and now onwards we'll render all the pipe that will be rendered first time will start from like right side of the our canvas. So let's say win width, it will start from win width, and with the velocity it will keep moving towards left. Okay, now we'll create the birds for each genome. So let's say for let I equals to 0, I less than genomes dot length and I plus plus. So what we'll do is we'll create a bird. So birds dot push new bird, and it will start from settings dot bird init that we have defined, and settings dot bird init y. Okay, it should be equals to. So once our bird is created, for each bird we'll add into this genomes at I. Okay, and before that let's say genomes so each genome will have a fitness variable that will tell like how fit our bird is, and it will actually help us calculate the fitness, add award for scoring, and to add penalty whenever it crashes with the pipe or go beyond our canvas. So this can be tracked through this fitness. So let's reset the fitness to 0. Here we won't use I since we don't have the size defined. Let's go with push. Okay, so now we have the bird and each bird has its brain. Okay, now let's say our running game will be tracked through this field. So whenever our like all the bird die and the game comes to end, for that iteration will turn into false, so that we can like go for next generation. And for each generation we'll have a score that our AI makes. So let's say score is 0, and then we'll start one while loop where we'll say it is running and birds dot length is greater than 0. That means at least one bird is alive and our game is running. So now like till now what we saw is here we created just one pipe, but as we play our pipes keep going and cross the bird, and the window will need to add another pipes. So that's why we'll have pipes also as array. And to compare, like when we are checking, let's say here we have the bird and the pipe has crossed the bird, so next time the collision and all we have to check with the next pipe. So for that one we'll create one variable. Let's say let pipe index is equals to 0, against which pipe we'll have to keep checks. And if pipes dot length is greater than 1, means if we have more than one pipe, and birds at 0, so whatever bird we have at the first position, if its x is greater than pipes 0 dot x plus settings dot pipe width, means if our bird has passed the pipe, that is what basically we are checking here. In that case our pipe index will become 1, so it will become the like next pipe. Okay, now what we'll do is we'll loop through each birds. Select I equals to 0, I less than birds dot length and I plus plus. So we'll loop through each bird So basically here we like decide for each bird, like should it jump or should it free fall, those things. So what we'll do is we'll create the inputs. Let's say const inputs equals to, as we have defined in the config, like we'll have three inputs and one output. So what are the three inputs we can use is, let's say, birds at I dot y, like where the bird is on the y axis. That could be our one variable, and then we'll use the difference, let's say, between the pipes, how far the bird is. So let's say pipes at pipe index dot y minus birds at I dot y. So this will basically tell us the difference that the bird has from the top pipe. And then we'll take again math dot absolute, and this time we'll calculate from the bottom pipe. So let's say pipes at pipe index dot y plus settings dot pipe gap. So this is the position from where like next pipe will start. Pipe gap minus birds at I dot y. So these three will be our input, and basically this should be an array. So we have three inputs, and then based on that we'll actually calculate the output for that bird. So we'll use the bird's brain gauge at I dot propagate. So basically it's saying we have passed the inputs, let's say inputs, it will propagate the input to the calculation and give us the output. So let's say const output. Now if you see here, we have passed the output as 1, but in cases there can be multiple outputs like 2 3, so it gives us the output as an array. Since for our case we'll have just one output, let's get at 0. This is going to be our output. Now let's decide if output is greater than 0.5, that means our bird will jump. Birds at I dot jump. Okay, if it is less than 0.5 means bird will not jump, and then we'll make the bird move. Okay, now bird has moved, and for every time like this run happens, means bird has survived till that time, so we'll give the fitness value. So let's say some fitness 0.1 will give as a award for like reward for survival. Okay, so we have moved the like birds. Let's go to check for pipes. So we'll create two variables. Let's say add pipe false. So with this we'll track like if we need another pipe, like once the pipe has passed the bird, those things. And then we'll have let remove pipes. So with this we'll check like if the pipe has gone all the way left and crossed the canvas. So those pipes we can add here so that it can be later removed. Okay, now let's loop through each pipe for that I equals to 0, I less than pipes dot length, and I plus plus. So we'll loop through each pipe, and we'll also loop through each bird. So let's say for let j equals to 0, j less than birds dot length, j plus plus. Okay, so here what we'll check first is if the pipe has like passed the bird, those things. So if, okay, now one more thing is if once the pipe has passed, this value will be set to true and it can keep adding the pipe. So to track that, what we'll do is we'll go to pipe and we'll add here one variable. Let's say this dot passed is equals to false. So once this pipe is marked as like passed through, so we'll add the pipe once and then we'll not add it later, like again and again. So once this pipe is now removed, the next pipe will come that will have default value as false. So again we can add next pipe. So let's come here, let's see. So if not pipes at I dot passed, means if it is not yet passed, and let's say pipes at I dot x is less than birds at j dot x. So in this case what we'll do, we'll make add pipe true. So we'll add a new pipe and also make pipes at I to past, so that it can add, like once it is set to past, this condition will fail for next birds. So it will just add for only one bird condition, it will check anyways, like x position of all the bird is gonna be same, so it doesn't matter. Okay, now every time the pipe passes the bird, so let's say here we had the bird and the pipe went left and passed the bird, will increase our score. So let's say score plus equals to 1, will increase the score by 1. And also we'll check if like score is greater than highest score, then we'll reset that. So highest score will become score. Okay, so let's say let b equals to 0, b is less than birds dot length, and b plus plus. So this time what we are actually checking is whatever birds are still alive that have crossed the pipe, so for those birds will increase the fitness. So let's say fitness plus equals to 5, so we'll give a 5-point reward for all those genomes, means all the brains. So these are the like better brains. So now this if condition is done, now let's check if the pipe has like collided with the bird. So within this loop we'll check if pipes at I dot collide birds at j. So we'll check collision logic and we'll add this collide method inside our pipe. So let's say collide, and it will take bird as an input, and basically it will compare the position of bird and the pipe current position. So it will decide like if bird has like overlapped the top pipe or the bottom pipe. So let's add that logic. So if let's say bird dot x plus settings dot bird width, so this is the like right part of the bird, if this is greater than this dot x, means if it is greater than the starting point of the pipe, and bird dot x is less than this dot x plus settings dot pipe width, means basically we are checking if the position of bird is within the range of pipe, like how much part pipe is taking, if our bird is within that, and then we'll check the like y coordinate of the bird. So and let's add this bracket. So if now bird dot y, if it is less than this dot y, That means our bird has collided with the top pipe. Or bird.y plus settings dot bird height, if this is like greater than this dot y plus settings dot pipe gap. So this is like a starting point of our bottom pipe. So if the bird's y position, like bottom part of bird has overlapped with the pipe, so if this condition is met, means we have to return true, means this is the collision, otherwise we can return false. Okay, so this is the collision logic that we have. Now let's go back here and see what happens if the bird collide. Okay, so if the bird has collided, what we'll do, first of all we'll give a penalty to the brain so that it will try not to choose that behavior. And then let's create here few variable. Let's say let rem birds, so whatever birds had collided will be added in this one so that it can be later removed. So let's say rem birds dot push birds at I, and also let's create let rem g's, so for that particular bird even the brain will remove. So rem g's dot push g's at I, not I, let's say we are using j, so let's use that one. Okay, now we have checked the collision logic. Let's come out and whatever pipe we have, let's move all the pipes. So let's say pipes at I dot move, so even the pipes will move, like all the pipes that we have. Now let's check if, like while after moving, if the pipe goes beyond the left side of the canvas. So like if pipes at I is less than 0, then rem pipes dot add, sorry, dot push, and then give pipes at I. So we'll remove those pipes whichever crossed the left side. Okay, now we are out of this loop. Let's check now if add pipe is true, means if we need to add new pipe, then let's push pipes dot push new pipe, and this will also start from the, like with the top right side, means like far right, and it will start coming left. Now like whatever we have in the pipes for removal, we'll start removing that. So let's say I less than pipes dot length and I plus plus, whatever we have in rem pipe, let's get that. So from pipes, let's get the index of rem pipes at I. So this pipe, what is its index in let's say the pipe object, pipe idx. So in the pipes object, whatever index we at whatever index this pipe is, we get that, and we'll remove that from the pipes. Let's say pipes dot splice pipe index pipe idx 1. Okay, so we'll remove one pipe at this index, and this thing will do if, let's say, pipe idx is greater than -1. So if the pipe exists, if pipe doesn't exist, means it will return -1. Okay, so we have the pipe that has moved removed. Now let's check the birds that we have. So first of all, let's check whatever bird that we have is within the range of canvas. So let's say for let I is equals to 0, I less than birds dot length and I plus plus. So if birds at I dot y is less than 0, so let's say plus settings dot bird height if it is less than 0, or birds at I dot y let's say if bird is greater than settings dot win height into 0.85, that is the area where bird can fly. Here also let's make it simple, let's keep like this only. So if we have this condition means in the rem birds will push these birds also, birds at I, and similarly for these also will push. Not in this, will push to rem gh. Okay, so now we have all those that we want to remove. Let's go and add the remove logic. So let's uh, copy this, and instead of pipes and anyway here we don't want to use pipes, we should be using rem pipe dot length. Okay, here also we'll use rem birds, and whatever rem birds we have that will search in the birds array, and let's say bird idx from birds, like if this bird index is greater than -1 means it exists. Let's splice sort it. Okay, so once we are done with bird, let's do the same for the genomes. So let's say rem ges, let's get it from ges genome index. If genome index is greater than -1, let's splice it out from ges. Okay, so we have removed all those inactive birds. So now once we have everything done, let's draw it on the screen. So util dot draw window, we have to pass context, we have to pass birds, we have to pass pipes. So it should draw these things there. We'll pass few more parameters later, but for now let's keep like this. So now if we run this game, what will happen, it will keep drawing, and it will keep looping through, and the game will be very fast. So what we'll do is we'll make it a bit slow. So let's add some ticking logic so that it will like let's say run 30 frame per second. So we'll go to util, and let's create one method here, and let's call it export. Okay, not here. Let's define static tick, and let's say it will accept fps, and this should be a sync, and what it will do is it will return one promise. that will resolve after, let's say, some timeout. So set timeout, and this timeout should be, let's say, 1000 upon fps. So how much fps we want in 1 second, that much, that many time it can run. That's why we set this one. Let's go here and let's say util dot tick, and for fps let's refer to settings. Go to settings and create one fps variable here. So let's say fps we want 34 now. Let's come here, settings dot fps, and let's await this to resolve. Okay, so with this, every 30 seconds our game will keep running and keep evaluating. There is one more thing that is left and we did not handle at that time. That is, here we just set the y to be 100, but we don't want this to happen this way. Instead, what we'll do is we'll get it randomly, so that we'll have a variance in the y. So let's go to utils again, and we'll create one method to get random numbers. So let's say static get random number, and here let's say pass mean and max, like between these two numbers only it will generate a random number. And let's use a math function, math dot floor, and we'll use math dot random. So basically it will give a number between 0 to 1, and what we'll do is we'll multiply it with let's say max minus mean plus 1, so it will get converted to the range that we have in between, like max minus mean, and then we'll add mean to it, so it will be greater than mean. And let's use this inside pipe here. So this will become util dot get random number, and what we'll do is, for now let's say it should have at least 50 as the like value, and so that we'll have like top pipe at least 50 unit wide, like 50 unit longer, and for bottom pipe also we should have some space. So for that one we'll calculate, like let's say settings dot win height into 0.85. This will be the like total height except base that we have, and then reduce the pipe gap from here, and then let's say we'll have at least 50 unit at the bottom. So between these range it will create this y. So we have this also set. Now let's go here. So once let's say all the bird die, and our game will come out of this while loop, then what should happen? So we'll come here, and before that, like our game can keep going till it reaches some maximum score. Let's say if the score reaches 20, we consider that our AI has played very well and we no longer want to continue. So let's say if score is greater than, let's say, max score, and let's create it for like 20 for now. So if it reaches 20 means we consider it has played well and it has learned how to play. So max score, then we'll make run as false, so it will move like outside the loop. And will also, we can add the fitness value, so that whatever bird is remaining will have the fitness greater than like the threshold fitness. So what we'll do here is g is at not I, g is of bird will increase by, let's say, 1000, the max fitness that we have, or let's say settings dot max fitness we have configured there. So we'll set to this one. Okay, now when we come here, like till the time we have not reached maximum fitness, what we'll do is whatever populations we had, we'll evolve it, so it will create fresh population. So whatever we had the last population, it will select the best genomes and do some crossovers and create the new set of genomes there. So we'll have the population created and we'll continue this loop until like we get the best genome. So let's say eval genome and let's pass the population again. So this process will keep happening. Now before this one, let's add one more thing. We'll return whatever value is from that best genome. Okay, now what we'll do is, if let's say uh, generation is greater than the max generation that we have configured, means we have crossed the evolution and all, and we no longer want like our AI to evolve. Or let's say if max fitness reached, like if any of our genome has reached max fitness, then also we no longer want to continue. So let's like create one method to calculate if max fitness has reached. Let's pass it genomes that we have left with, and what we'll do here is we'll loop through all these genomes. So for let I equals to 0, I less than g is dot length, and I plus plus. And if let's say g is at I dot fitness, if it is greater than settings dot max fitness, then will return true, otherwise will return false. Okay, let's say it is a function. Now once this is reached, what we'll do is from population we'll like get the best genome. We have this method that will select the best genome out of this population, and let's return this one. So after the complete evaluation, or either we reach max fitness or maximum score, we'll get the best genome out of this. So now let's come to our main file. So let's come to this one, so where we are evaluating this genome. So what we'll do is we'll say const best genome. So this will be the best genome after evaluation that is returned from this method. And what we'll do is we'll save that genome into the local storage of our browser. So let's say set item, let's name it best genome, and save this one best genomes dot. We have like two JSON method that will actually convert this genome into a like JSON, so it can be actually saved or transferred and reused anywhere. Okay, so now we have this ready. Let's try to run it and see if this training goes well or we are facing any issue. Let's go to our browser and let's try to run train AI. So nothing happens, some error might have come. Let's see. So it is saying neat JavaScript is not defined. Let's try to import it. Now if I try running it again, still it is not defined. Okay, so it seems like there is some typo here. It should be neat JavaScript as uppercase. Do we have it anywhere else? No. Let's check now. So now we have pipe gap is not defined. So okay, so here it should be settings dot pipe gap. inside our pipe. Okay, now if I run this, so something got rendered but it's not proper. Okay, to JSON is not a function. In promise, if I go to our new trainer, so here if you see it is async, so it will give a promise, so we should await for it to complete, and then it should give us the value. If I run it now, still something, so it is calculating displacement and all, but we can't see any pipes. Let's try to debug it. Okay, so one problem we have here is should be increasing the fitness, not the GEs. Let's see now, still nothing. Here also it should be fitness. Here also let's say fitness. Here also fitness. Here let's say if pipes of I dot x is less than 0, then we'll add it for removal. Okay, so here we should resolve once this is like tick is done. So I think that was not happening. Yeah, so now it is working. So now we have a couple of things left. Let's first do that, then we'll check if there is any issues. So here if you see, let's go to the trainer. Let's remove this loggers for now. Okay, here if you see for the drawing we only draw like bird and pipe. So what we'll do, we'll also pass let's say score, highest score, and the generation, and let's get these values there and let's try to draw it on screen. So once we draw all our pipes and all, we'll go for drawing the text. So we'll use a fill style of, let's say we just want to draw in white color, so let's say FFF, and then we'll use a font, text dot font. Let's say we want it to be 24 pixel and Arial font, and then ctx dot fill text, because we want to fill it with text, and here let's use this so that we can interpolate our variables. So let's say score colon and give dollar, and it should actually add the score from the variable. And once this is done, we have to give the position where we want to draw it. So for now let's say 350 from x and 30 from y. We'll change it if it is to offset. Okay, we'll use same, and let's give highest score, and here we'll use highest score variable, and let's say we want it to be from left side, so we'll just keep 10 offset, and from top let's say 30. Then we have generation, so let's draw that, let's say gen, that is what we used, and let's say for this one we'll give offset as 50 from top, and I will draw it on the left side only. And then let's say we want to draw birds alive, this will become our birds dot length. Let's store it on 70. Okay, with this all the drawing will be done. Let's run it now. So we have couple of issues. Okay, birds dot length, it is not a function, it is just an attribute. Yeah, let's try now. Okay, one more thing I will do. For now, just go to style.css and change it to row so that my buttons come on the left side, and even if I open the inspect window, it will not go off screen. Okay, something happened and it is stuck there. Let's see. Pipe idx is not defined. Okay, it is by idx. Some typos is there. So it should be pipe index. Let's run it now and let's see. So score is updating. Our highest score is updating. Birds alive is updating. Pipes are coming. Bird is flapping its wing. Okay. Okay, so it seems like it's too easy for the bird to play. So let's make it a bit difficult. Let's go to settings and reduce the pipe gap. So now we have pipe gap 150. Let's make it 100 and let's see. Let's train again. So now the gap will be shorter. Let's see how many generation it take the bird now to reach score of 20. Okay, in generation 1 it made till a score of 9. Okay, seems like the bird is facing issue flying till there, but it is trying. Let's see for a couple of more generation. So it has actually reached 20, but since I have given the condition like greater than, so it did not check for the equals condition here. So it like wanted to wait till score is 21. Okay, anyways, let's see how it plays now. So it reached score 21 and it stopped, and it should have saved the best genome file. So let's go to application, local storage. You can see best genome is saved in the local storage as a JSON. So now we'll load this and we'll see the AI playing.